Here's the cap WAP state. Hopefully I did my monitor sessions correctly. All right, there we got some cap WAP controls. Oh, there's some messages. Discovery. All right, it's looking good so far. Awesome. I remember I said packet 346, 341 was where we wanted to start. Quantum Delta, you've got 20 units in total for Cisco, all running close to capacity, a mix of N+1 and SSO. All right, that's a good setup. What version are you guys running, Quantum Delta? All right, so AP is fully joined to the controller, all right? We've got a good setup here. So first, let's do debug, disable all on the controller. Charles Byron, you're still using controllers and using several Cisco models. All right, I like that. Very cool. So AP on the left, already joined to the controller. Let's look at the controller right now. I'm going to stop my Wireshark capture. I'm going to go back to the controller because we want to see these messages. And there's quite a lot here. So maybe if I can expand this window, there you go. That looks easier to read. So you can see here, after we had rebooted the AP used to be connected to the controller. Then on the AP, I told it to erase all its CapWAP config. The controller then noticed that the AP has been down for quite a while. So you see this echo timer expiry, which then it goes into disconnecting its existing DTLS CapWAP control session for that AP. There's a teardown. And then we start looking at, if I'm looking at these timestamps because I just want to ignore all the messages where it tears it down. All right, so there you go. Here's where we start then with the AP joining to the controller. There was a CapWAP control message received from the AP. That's my AP's IP address on this port. All right. And you can see start of the CapWAP packet, the control message. It's a CapWAP discovery request. And here's the model of the AP. Starts going through different messages here with the controller. Some of these messages I never remember what they mean. Like if you were just looking at these messages, you have to understand what they mean and try not to get hung up on specific messages like this. All right, sometimes that doesn't mean much in this case. So here's the discovery request. This is coming from the controller. This is a debug command from the controller output, and it's saying, "Hey, I got a discovery request from this source IP and port." Here are the message elements, AP model, different message elements, which I don't know what these are. Cisco has some documentation on this, but it's very hard to find in my opinion, and I always forget to save it. So here's the vendor specific payload from the AP, right? So that was at 8:16:58. Join priority processing. So it's now starting to look at, all right, let's take a look at the controller. I have a max license of 5 APs that can join. Here's the AP model, the bundle image version that we're running, the AP is running. And here's the controller name. And then here are more CapWAP control discovery response. So there's the controller responding to that CapWAP request. There were 2 that the controller received, I believe, and 1 probably to the IP address directly, and then 1 that was a broadcast. And then eventually DTLS starts to be built. And as you can see here, this is also a key for an AP to join. You want to be sure these DTLS sessions are established. So there's a DTLS session established between the AP and the controller. And some more CapWAP packet messages that we're receiving as part of the debugs that I issued. Now, if you did have any errors, we would see errors here too, because I did run a debug CapWAP errors enable command. And so there it is. It's joined. Then there's going to be a variety of CapWAP messages sent between the controller and AP. But now let's dive into Wireshark, because we can see some interesting information here as well. So I'll start here at packet 815. This is where we see this request. So you can see that the AP actually sent a broadcast request on the network, CapWAP control discovery requests. Wireshark either doesn't know what to do with this packet, or there is actually something wrong with it. There isn't anything wrong with this packet because the controller responds with a CapWAP control discovery response. So if we take a look at this request again, you can see it is source from the AP to the destination broadcast. Here is the source port 5272, which we saw back on the controller. The controller saw that message. It received the CapWAP message from that AP on that port. Same thing that is happening here. The destination port is 5246. You can see some of the CapWAP messages. Here's the preamble. It is a CapWAP packet. There's the MAC address, the control header. So this is why I like diving into Wireshark, and why you should understand how to use Wireshark to really capture what's going on. So that's a broadcast address, right? And then the controller will respond to that request with a CapWAP control message or discovery response, as you can see, with the source being the controller, destination being the AP. Source port 5246. Remember 5246 in the beginning of the stream where I said the CapWAP control message is 5246, a UDP, right? So it says UDP right there, 5246. Here are some more details in that CapWAP response. So let's kind of dive in. Here's the message elements of that CapWAP response. Remember, if you saw me scrolling on the controller, we saw these packets on the controller. Right, so if we go to if I look for descriptor, there it is, right? CapWAP message element AC descriptor. There's that AC descriptor right there, and we can see active security flags, DTLS policy flags, AC information. We can kind of see, diving in here, what these CapWAP messages look like. If you really want to dive in, I think this is beyond the CCNP objective of just describing access point discovery. I don't know if they will actually go into the detail of the packet, which would be great. Here's the CapWAP IV control IP address, MWAR, payload, lots of good information here, right? And then we talk about DTLS. So there is a certificate that is exchanged. There's certificates on these APs and on the controllers to verify that we are dealing with a Cisco AP. So the AP then sends a client hello. You see these certificate exchanges. They verify the certificate, and that DTLS connection ends up. DTLS is datagram transport layer security. That handshake ends up completing. There's that certificate verify